And I'm a Senior Systems Engineer for Neverfail. So you're probably wondering why a person from a water company is coming to talk to you. Well, water is interesting, but Neverfail is actually an international company that started in the UK, and we deal with continuous availability. And as this is a technical forum, I'm going to focus on the technical aspects and try and just bypass most of the marketing. So have a nice cheer about that. Let's see if we can get this going. I have to click the button. Right, so yeah, Neverfail is a global software company. Our value proposition is no user downtime. So we want to keep the user continuously connected to your applications. About 10 years ago, we started as a DR consultancy company. We were driving a truck around with servers and workstations and switches in it, and if you had a disaster, we'd come around and we would set up a new network for you. We realised that that was quite a slow turnaround, so we decided that it's time to develop some software to do that for us. The majority of our engagements are regarding like a cluster type solution where they require less complexity and less cost. We've got over 3,000 customers, ranging from SMB through to enterprise, and that's not including our OEM agreements. We are one of 50 Microsoft independent software vendors, and our OEM agreements are with VMware, SolarWinds, Cisco, and we do have many more. Has anyone heard of the vSAN Server Heartbeat product from VMware? Okay, a few of you. That's the product that VMware OEM from Neverfail. So they've looked at our product against all the other competitors and decided that our product's what they want to do to protect that vSAN server. So before we go too far, let's just put some definitions out there so we're all on the same page. I don't usually like reading from a slide, but I will for this so that we get it right. So the recovery point objective, or RPO, is the maximum desired time period prior to a failure or disaster, during which changes to the data may be lost as a consequence of recovery. Data changes preceding the failure or disaster by at least this time period are preserved by recovery. 0 is a valid value and equivalent to a 0 data loss requirement. We've also got the RTO, or recovery time objective, and that's the maximum tolerable length of time that a computer system, network, or application can be down after a failure or a disaster occurs. So we really specialise in meeting the recovery time, recovery point objectives. Rightio, so I'll quickly just go through the evolution of the continuous availability. Over time, people started with backups, and we used to do that to tape, and then we went to snapshots. We moved into data replication, which was snapshotting, asynchronous and synchronous replication. Then we went to like failover, virtualization, clustering, and then what Neverfail has done, we've actually developed this new segment, continuous availability, about bringing in, having users continuously connected no matter what the failure is. Death by slideshow, hey? So, let's have a look. Our core product is Neverfail Heartbeat, and that's a host-based availability solution. It's an active-passive cluster software, and it sits on Microsoft operating system. So it doesn't actually require VMware below it, but it works really well with it. And we'll get to that a bit later. As I said, it's set up in an active-passive cluster, and actually manages the replication of your data between the active and passive, and also the failover processes. It is application aware, and we can actually meet near zero recovery time and recovery point objectives. How about we go into a bit of detail on how this system works? So essentially, you take your primary server that's got its operating system and applications already running. In the event of an install, we'll just make that your production server. So let's say it's an SQL box. So you just take your first server and you add a second. So this can just be another virtual machine, just with or without the operating system, depending on which method you want to use for install. We essentially need 2 NICs in either server, one for the channel, which is, you can use a crossover cable, you can use a virtual switch, and then your primary network, LAN or WAN. So we install that, and then what we do is we install what we call our scope tool, and that analyses system performance, analyses the bandwidth requirements for replication, and identifies any issues that could occur during the install and during production. So we identify those before install so we can address them, whether you need more RAM, whether there's not enough CPU available, and so the overhead that we apply, we'll set it over the top, something like that. And then what we do is we actually clone the primary server onto your secondary. You can do it a couple of ways. The easiest way I've found, VMware, right-click, go clone their machine, and that gives you a second. And what we're trying to achieve here is the exact same identity of the machine, same IP address, same name, and even when it comes to Active Directory, same SID and computer account. So we've got two identical servers basically. And now what we do is we apply a packet filter on that second machine. So you haven't got two machines with the same IP address and the same name on your network, you've just got one. So we hide the second machine from the network. So what we do is we begin to replicate the changes between the primary server, which is your active, and the secondary, which at the moment will be your passive. And so any changes that occur to that primary machine, we just send them across and apply them in sequence to that secondary server. And what actually happens is that we sit at that Microsoft I/O stack, so we've just got hooks in there. When we see a change, a write change to the data that we're interested in, we just replicate that change in sequence to the secondary server and it writes it to the data. The secondary server doesn't actually have its services started, so for instance if it's a SQL box, those services are set to manual and off, and so the data is not being used, so it just writes the data just like it was if it was on. Neverfail will detect a failover of the application and will actually switch across the packet filter, or remove the packet filter from secondary, revealing it to the network, start the services up and present to the network and continue operating as if there was no failure at all. So essentially, from a user perspective, as long as their client can do a reconnect, it doesn't require being shut down to start up, for instance Outlook. It'll just look for the server, it'll find the new one and it'll just connect to it. There's some funky stuff that goes in the background, so you might be thinking, well, what about the ARP tables of the switches and of the PCs, that kind of stuff? Well, we do an ARP flush. We send out a request to flush all the ARP caches. So once we've addressed the failure, we can resync in the reverse direction. So we can go from the secondary at the moment, which is our active, to the primary, which is our passive, and we resync the other direction and bring it back into sync. And then we can actually switch back, so we can actually make the primary our active again. So let's say you've stretched this over a WAN, you've put the second machine in your data center, and you've got your primary on site, your primary's failed, you've failed over, you fixed the issue, you brought it back up, resync, and you can switch back just with a click of a button. Actually manages the DNS changes if there are different IPs on the servers as well. Rightio. So these are the topologies that we support in terms of how we can deploy. So the first one is just a local LAN HA, two servers in your local network. One goes down, the other one takes over. Second is DR, where you put your second machine off-site. We can use a cloud, we can use a data center. As long as there's a connection with the specific ports available, it will work. We can actually protect the Microsoft cluster. I won't go into too much detail because we actually prefer to replace the clusters. And being VMware users, you probably also want to. So we actually replace it. But in the case where they don't want to get rid of the cluster, we can actually give them the offsite DR. And then the fourth option is our tertiary option. We call it a trio. And we've got two servers and a local HA and a tertiary offsite. And you probably see a WAN smart there. That's one of our modules that allows us to reduce the network traffic. And I'll get into that later. In fact, now. So one of the things that Neverfail does is we don't actually replicate standard system data. We actually, because we don't clone of the operating system, it's a separate OS and we don't replicate operating system changes. And one of the reasons for this is so we don't actually have to protect against fail. So we actually protect against failing of the operating system patches or of the operating system itself. So you can patch them independently, and if there's a problem, the other machine, the other server will actually keep you running. We also do continuous replication, so snapshotting might be every 15 minutes, we just have it going all the time. And you can compare that really to two streets, 70 kilometres an hour each. One's got traffic lights and one doesn't. One manages congestion and the traffic a lot better, and that's pretty much how we've addressed it. We do it continuously. We also can implement compression and deduplication on the through our software. We don't require a third party for that. Okay. There was a Gartner study that went across, and what they did was they looked at why do system, applications fail, and they identified that 20% of the issues were environmental. So if we're only protecting against network and hardware-based issues, we're really leaving ourselves open, and we're not addressing all the risks that's against our business. So let's take a look at the ecosystem. It starts with the data, obviously, but without the systems around it, the data's pretty much useless. We've got the hardware and operating system, we've got the network, we've got the applications, and we've got our users. I'm going to go into a bit of detail, and I'll run through this detail fairly quickly so I can actually get into the demo and show you the guts of the system and how we apply, how we protect all of these aspects. So let's take a look at the data. So we actually keep 2 copies of the data. Like I said, we replicate between 2 servers, keeping 2 separate copies of it. We also replicate asynchronously and in real time. So we're not actually holding up the primary server while we're writing the change to the secondary server. In some instances, that replication, we've seen it happen on a local LAN. Actually, VMware, we talked with some of the guys in Adelaide for the VMUG there, and they were doing a test on the vCenter server Heartbeat. They were running this test against, and they're putting an immense amount of load of write changes to the primary server, and then they just pulled the plug on it. And what they saw was that because of the disk queue length on that primary server, the secondary server was actually more up to date than the primary. And I found that quite amazing, but because the way that we replicate and apply the changes, we actually do have what's called a send and receive queue, so the active server will be sending the data, so it identifies the writes, puts it in a send queue, then it transmits that over the wire, the passive server puts it in a receive queue and then writes it to the disk. So anything that's in the send queue, if that server was pulled, you'd lose, but anything in the receive queue would write before taking over. We use plugins to identify data, so for instance a SQL server or Exchange, if there's a new database added, would identify that database straight away and add it to our replication set. Same with transaction logs and the like, so you don't have to actually go and manually update what data you're interested in. And we also do protect against data corruption. So on our passive server, we can set up a snapshotting VSS, so that essentially in the event of a data corruption, yes, it will get replicated, but on the secondary server, you actually go back in time and say, well, take the snapshot from 15 minutes ago, make active, and that server's available. So yeah, we can actually protect against the data corruption as well. Sure, you're going to lose a little bit of data, but the actual time it takes to recover from a data corruption without Neverfail could be quite more substantial. We've got the hardware and operating system. We monitor for system availability. We look at system load, and we can use corrective action. And we also we can assist with the system maintenance, like I mentioned before. We can do you can do patching on your passive server, reboot it, make it active, see if it works. If it does, then do that same patching on the other server and reboot it. So you can actually keep your systems online while you're doing your system maintenance. Yeah. Next one is the network. We actually do ping tests to make sure the network is available. So you can identify 3 targets on your local LAN and say ping these, and if you can't get to them, then your network's failed and do something about it. We also protect a bit against the Neverfail channel failure. And as I mentioned earlier, we have the channel to do the replication. It's also used for monitoring. If that channel fails, in a normal instance, you get what's called a split brain. Machines won't know if each other's available or both will be active. So what we actually do to address that is we set up a communication outside on the primary network. So in the event that the channel goes down, it checks to see if that server's still available, so to avoid that split brain. We actually call it split brain avoidance, funnily enough. Yeah, applications. So we actually do have our fingers into the application. We do monitor and control the important services regarding the application that we're monitoring, that we're protecting. So for instance, the SQL server will actually have our fingers on those services. If they go down, we can have corrective action. One might be just restart the service, one might be switch over to the other server. So And we also do a deep dive into specific applications. So we support like IIS, SQL, Exchange, SharePoint, and we actually get into the nitty-gritty of what that application does and some metrics behind it, so that we can monitor those as well. So the example I've given here, IIS for instance, it will check for website availability, it will check for the response time. So we can identify these issues and put corrective action around it as well. And I'll show you those a bit later in the demo. And now we do actually integrate with VMware, so here's what you're all been interested in, I'm sure. What we can do is we can actually, instead of using our GUI, you can use a vSphere GUI. You've got a plugin so that you can manage it from there, from the vSphere client console. And we also can extend Site Recovery Manager to physical servers. So if you've got a couple of physical machines that you just can't get off physical for whatever reason, maybe application support, then we can actually, with a Neverfail pair in that regard, we can include those machines in your SRM recovery plans. And I'll go into a bit more detail about that. So yeah, we use the OEM relationship with VMware to be able to get into their console. We support versions 4 and 5, and we can manage those virtuals and physical machines together. And this is just a screenshot essentially of how we do that. We've got the vSphere version 5. We're running a physical server there, we've added to the console. We've actually grouped them by business application, and that's a nice little feature that we can do as well. In terms of protecting, so if you've got a few tiers, you don't want one go to your data center and the other stay local, so that we can actually group them as a application unit and move them together. And we support SRM. Okie dokie. So how do we integrate with SRM? Well, what I might do is I might just use the whiteboard here and just come up with a bit of a scenario to help explain how it all works. So let's just say we've got 2 sites and they're connected via the internet, mobile WAN connection. You've got a couple of hosts, host A, host B, and these are your ESXi servers. Put a little storage device in there. They're all connected to. They're connected to a local WAN, a router. And we do the same on the other side. Call this thing there. So what we can do is SRM obviously manages all the virtual machines, the replication, and the failover and testing. What we can do is we can actually add, so you might sort of have 4 VMs sitting over here, and they're also replicated over here. And with SRM, with a click of a button, you can send it to your other site. We can actually add a physical server to that, so we'll have an SQL one. And so with a Neverfail pair, we just connect it to the network. We're going to call it the same name because we keep the same machine name. And in our plans, we just add a line to basically tell Neverfail to switch over at the same point in time. So if you do use SRM and you're trying to work out how to address these other these physical machines, then we can assist in that area. Before I go on, how about we do the demo and get into the guts of it. Won't be a moment. I think this is working. So this is our basic console. As you can see, I've just got a primary and secondary server set up. And I can identify just quickly that it's all going okay. Yep, replication's working, the application's started, the network's all right. I can see that it's all synchronized and that my secondary is 0 milliseconds behind. So there's no queue essentially waiting to be soon. I can easily just make the secondary active, just like that. But what we might go into is just a few of the configurations that I talked about. We're protecting the ecosystem. So we'll start with the network. As I mentioned, you can set up 3 different targets to ping, and you can also configure what to do when you've lost ping. Yep, switch it over. We want to go to the other server when you've lost those pings. We also plug into the application. We'll just go into plugins a bit more. The plugin helps us identify what data to look at, what registry entries that we need to replicate, and also what hooks we need to monitor in the application. And so it's easy just to install an additional plugin. So for instance, if I wanted to make my IES SQL server a file server as well, we can install a plugin with a set to do that as well. And that'll help, if you add a share, it'll pick that share up automatically and add it to its set. We monitor the servers, as I mentioned, the services, should I say, and we identify which services are related to what plugin, plus also we can add customized services if we want to manage those too. We've got tasks on what additional to do when you switch over, when you fail over, those kind of things. And then the rules of the nitty-gritty of what are we monitoring and what do we want to do when this monitoring hits a threshold. So I mentioned earlier on database availability. So we can actually go in and edit this, and basically it says if I can't run this store procedure against each database with a timeout less than 20 seconds, then do something. And I've told it to restart the applications. So it'll actually go and restart all the services to see if it fixes the issue. But the options are switch over or just log a warning. Both servers are supporting, we can send SMTP stuff to your mail server so you can get alerts based on any issue that's there. Okay, and then in terms of the data set, we can just check that it's all synchronized. We can tell it to do another check. The file filters, which are the IIS and SQL ones, are identified via the plugin, but we can actually add inclusions and exclusions manually. Data rollback, this is the one that protects against that data corruption. And as you can see, my secondary server's got a few different rollback stages. I've got it running every 30 minutes. And it also manages them, it doesn't just keep them forever. And you can tell how long to keep each snapshot. So you're going to say, well, I want to keep 5 a day, and then I want 2 for a month, and then I want 1 for 3 months, that kind of stuff. So it obviously doesn't take up a ton of disk space. Then we can look at the traffics and the queues, and I mentioned that earlier. As you can see there's a queue in the primary server send queue. It's 17 seconds to go. Each entry in the queue. It all depends on the write. Because when you make a write change, it just replicates that write change. So my demo environment isn't the fastest. I've just basically got a PC running VMUG workstation. So things do take a little bit longer than a normal production. And then I mentioned earlier we've got that WAN compression. So we can actually compress the data and deduplicate it to reduce it across your WAN slowly. Radio 1, we turn off our primary server and see how it goes. As you can see, my recovery point is at a minute. It's not very good. I wonder why that's doing that. It's funny that you practice it and you run it 10 times and it all works fine, and then the moment you want to display it and demo it, you've got troubles. Anyway, let's turn off this primary server and see how the secondary reacts. I've got it set to a 20-second threshold, so when it works out that it can't find the server, it waits 20 seconds and then fails over. So here we go. Just power this sucker off. Okay, so we've got it off now. While we're waiting for that to go ahead, does anyone have any questions?
Just with that physical SQL block, does that mean redundant physical hardware separate, or does that mean the physical become a virtual once it's pushed over?
Well, actually, that's a good point. We haven't actually touched on that, but we don't actually matter whether it's a physical or virtual. So you could actually make the second SQL box in your virtualized environment. So you might have a requirement here that I need a high capacity server, so we're not going to virtualize this. but in a DR environment, well, we'll get by. So let's put it virtual. So yeah, we can do P2V, V2P, and all the combinations. So as you can see, it's identified that that primary server's now died. And yep, I've lost that active server, so we'll wait 20 seconds to see whether it comes back up. One of the things that's worth noting as well is that you can actually configure, if there is a disconnection between the two servers, you can configure how long to keep that, the send queue. So you can configure it by size, you can configure it by time. So in the event that your secondary server's dropped off, to actually do a whole resync, it's got to go and do checksums against all the data on both sides, which obviously is CPU intensive. So if it gets to a threshold where it actually does become out of sync, you've got to do that. But if it comes back online within that time frame, you can actually just pick up just what needs to be replicated rather than having to resync it all. So as you can see, that secondary server now has just come up, and it's active following the failover. So that took, what, 40 seconds? Something like that. So if I've got a website, it really does prevent me, if it's down, I could lose revenue, I could lose productivity, reputation, all those kind of things. So this is my demo website. So I can actually just refresh that one. And now it's running off the secondary server. You can see it was 459. Yep. So actually bringing up the secondary machine, it's a matter of fixing the issue, sorry, the primary, fixing the issue, so we'll power it back on. And once it comes back online, the Neverfail services start, reconnects to the secondary server or the active server and says, what do you want me to do? It says, yeah, let's resynchronize. So it checks all the data, brings it back up to date, synchronizes all the changes that need to occur, and then you're good to go again. So that'll take a bit of time, so I won't go too much into the recovery point. But any other questions while we're there? At the back?
The IP changes, can you show us how the IP change is being done? If we don't have a span VLAN on the other data center, then would this be a possibility? Yeah,
so what you do is you have your secondary machine with a different IP address, and you use DNS changes to identify that. Sorry, we use DNS we actually do a change in the DNS as a part of the failover process.
Okay.
So we support Active Directory, DNS and bind. So essentially, in the process of failing over, it makes the changes to DNS. So clients, when they go, okay, I can't communicate with that server, we'll do another DNS lookup, and then it'll get the new IP and then communicate with the one on the other side. So,
do they know? Do clients do that? You web browser just because you can't communicate, it doesn't force the client to do a DNS lookup, does it? So it takes 10 minutes to pull that DNS entry times out.
Usually what you do is you set the TTL quite low as a part of the setup, so that when it does try and reconnect, then obviously it's lost the record, so it has to go and query again. Yes, that's right. Yeah, so that primarily be internal, unless you're running like an external web server, but you can actually address IP issues differently for external stuff.
Do your TTLs flow through to say ISPs necessarily? But they independently can set their TTLs, can't they? Regardless of your TTL on the DNS record?
The TTL is set on the zone, I believe, but also can be configured as part of the DNS server, correct me if I'm wrong, in terms of the DNS server that's providing the information. But we haven't had any issues with this in terms of updating records and having clients reconnect. I've done it myself, but I haven't actually gone into the specifics you're talking about. Yeah, as I said, when you send the TTL and the clients can't connect, they usually reach out and find the new address and then connect to it there. As you can see, it's quite slow and booting. Is there any other questions?
Is that the only way? Sorry, you mentioned that you can do an up flush. How do you make it?
I'm not 100% sure of how it goes about the arc flush, but I believe it's just a broadcast that sends out, and all.
So that everybody else can hear.
So is it maybe a guard that says, I'm now this?
Or flush your cache. Yeah, don't use what you've got, go and get new stuff.
So does it interact with network devices like load balancers?
we might not keep waiting on this one. We might just move on. If I can work out where it is. I haven't got too much longer, but feel free to ask any more questions as we go. Yes, absolutely. Right, so just a couple of scenarios. Sorry, one back. A couple of scenarios you can use it for. If you've got a Microsoft cluster, traditionally putting that into a virtualized environment doesn't get all that happy with. So we can replace the cluster and be on the virtualized environment. We can extend SRM to those physical servers, like I mentioned. We can protect those critical applications that just can't have any downtime. We've got a customer in Adelaide who had a server fail due to Windows patching and cost them $15 million because that server was offline for over 16 minutes. So they put our software on and the application vendor tested it and now is certified Neverfail against their application. But when you think about having downtime that affects your reputation, affects your revenue, productivity, they're the applications that we really thrive on protecting. We address the low bandwidth issues, as I mentioned earlier, and we can actually set up a full shared nothing environment. So it doesn't matter what storage you've got on either machine, whether it's an iSCSI target, a SAN, or a local disk. As long as it presents to the OS as a local disk, we can work with it. And obviously you can do everything else around the shared nothing as well, multiple WAN links, those kind of jazz. So if we bring it all together, whether your environment's physical or virtual, we can help with your DR objectives. We can help protect your business from productivity loss, loss of revenue, loss of reputation, loss of confidence by your IT users. We do have a trial where you can use SRM Extender, and that's the website there. And if you want to give us, send us an email or check us out any further, those are the details. Craig. Just to reiterate what Craig said earlier, we've got some questionnaires on the table. Just fill them out and put them into a hat and draw one for the go-towards to win the Bose headphones.
Yeah, cool. Yeah. So, any more questions? Anyone have any more questions they want to ask regarding the product? We've got a Q&A. I've got a lot of people in the room here. Sorry, someone's got a question. Come on, I've got some prizes to give away. I need some questions. Okay.
I was just wondering how tight the integration with SRM was and how easy that is to set up.
Haven't done it myself, but supposedly it's a matter of just adding a PowerShell script into one of the lines of your SRM plans, and that PowerShell script interacts with Neverfail and says, okay, yep, switch over. So it's just a simple command, just like clicking the Make Active button that I showed you earlier.
Thanks.
With things like SQL, you're replicating the database. Are you replicating all of SQL, including all the application data of SQL?
It's a good question.
So if you make a user account in SQL, will that come across to the other box?
Yes, we do support the permissions and the like.
And config data, the actual one
and
itself.
config data, yeah, and things in the registry that's associated with it as well. So yeah, we replicate that.
Patching?
No, we actually don't want to do the patching. The reason being is patches don't always go great, so we want to protect against that.
So if you're specifically looking at SQL and determining what data you want to replicate out of that?
I believe so, yeah. I haven't done a patch on my system myself, but we advise when you do patching at any level to do it on a passive server and bring it up, make sure it works. And when you actually are doing, say for instance, application patching that's making changes to the schema and the like, what we actually suggest is to break the replication, do it on your active server so that it updates the database, updates the application data, and then do it on your passive server before you re-replicate so that you're getting a consistent set of data, and then you set the replication back up and go from there. So there's a few different ways of doing your patching depending on what the patch is changing. Another one, to further answer your question, got asked this the other day was, what if I don't want to have to do things on both servers? What can I do? And the answer was, well, just clone your primary server again. We don't care that it's got the software. You clone it, you make some changes to the IP addressing, make some changes to the application to tell it's secondary rather than primary, and it will just set up and go. So you can patch one and then just clone it so you don't have to do it on a second time.
Any more questions? Yeah.
Pricing model?
You'll probably be happy with the pricing model. We do half price for virtuals. So it's 5k a pair for a virtual pair. If it's physical, it's 10k a pair. And then we've got add-ons based on the modules. So whether it's an SQL, IS, that kind of stuff. And they're usually about, I think it's about 15% add-on for those kind of things. I'm not the salesman, I'm the technical guy. But that's the gist that I get.
And how do you rate, or what differentiates you from competitive products?
Some of our competitors are like Exosoft and DoubleTake, and the real difference is in how the identity is handled. With DoubleTake, for instance, they actually change the identity of the machine at failover. We handle that identity issue at install, and that's the real crux of it. You really want to be stuffing around with identities and IP addresses and Active Directory when you're recovering from a farm. We want to do that in preparation, and that's how we. That's really a big differentiator with us in DoubleTake.
One more? Last question?
Yeah, just about G-code about the encryption method.
Just
about
mate.
G-code about the encryption method to the DR side?
No, not at all. We don't encrypt, so that has to be a third party, but we don't really care. As long as we can get IP connectivity, we can handle it fine.
Okay, I think what we'll do, Glenn, is I don't know if we're going to call out a couple of prizes there. We've got a few things to give away, so I don't know, Tony, if you want to, I don't know. Okay, yeah, so we'll let you go ask him then. Okay. Did you say you want to? What have you got?
I've got the prize money.
Yeah. So you get over there now. I'll call now. Thanks, man.
I like your one.
Mark, what do you want?
I'll tell you what we've got, yeah.
You want to come up here and
Yeah. Come on, mate.
within the context of